Today we're going to learn how to find the intersection of a line and a circle given the graph of the circle and the equation of the line. Should be pretty easy. Look at problem number 1. Here's the equation of a line, here's the graph of a circle. We need to find, the way the problem is worded, solve the system of equations given by the line and the circle. Alright, but a system of equations is just a common solution between two sets. So that's going to be the intersection of the two graphs. So that's what we are really finding. So the best thing to do is to graph the line and see where it meets the circle. So I like to rewrite these equations in slope-intercept form, y equals mx plus b. So to do that, I'm going to subtract 2x from both sides. And so that's going to give me y equals negative 2x plus 14. Now normally I would go, okay, look, the y-intercept is 14, so I'd start at 14, then I'd go down to right 1. But 14 is way off of this graph. So I'm going to need a different strategy. Let's put this equation in our TI-30XS multi-view. Help me remember it. It's negative 2x plus 14. Remind me when I get over there. Let's see. So you hit the table button and you type it in. What was it again? Okay, that's right. Negative 2x plus 14. All right. So we hit enter. And sure, why not? Start at 0, whatever. Okay, so sure enough, it starts off at 14. That's way off the charts. Let's see where our chart begins. So 7, 8. Alright, so y value of 8 is as high as we go. So 3, 8 is on the graph. Okay, so 3, 8 would be right here. Alright, and then we know it's going to go down to right 1 from there. So it'll be down to right 1, down to right 1, down to right 1, down to right 1, down to right 1. Now if somehow you did not know that the slope worked that way, and I could read it to go down to right 1, well, you know, we're already looking at the table. So you could have looked at this and seen, oh look, 4, 6, 3, 4. So there you go, 4, 6, 3, what did it say? 4, 6, 5, 4, sorry. 5, 4. So you could have gotten these values off your calculators, is my point. As you draw that line, hopefully you can see easily the points of intersection are here and here. So these are the solutions to the system. And this is the point 4, 6. And this is the point 6, 2. Alright, so these are the solutions to the system. Alright, let's do the same thing with number 2. Let us add x to both sides. So far that's going to give us 3y is equal to x plus 6. Now let us divide by 3. Alright, we have to divide by 3 everywhere. Okay. Understand that x over 3 is the same thing as 1/3 x, by the way. So, in fact, maybe I'll just write it that way. So next we have, because these 3's obviously cancel out, so I have y equals 1/3 x plus 2. Let's see if we can graph this without the calculator or not. This 2 right here is the y-intercept. So that means we can put our first mark at 2. This 1/3 is the slope. rise over run, up 1 over 3. So let me make sure the scales are the same. So I'm going up 1 over 3. Okay, up 1. Alright, over 3 is going to be really off the grid. But still, I can draw the line pretty well. So let's go ahead and draw that line. Okay, it's definitely going to go through these 2 points for sure. Okay, I had to guess at that other one a little bit, but what are you going to do? Actually, it wasn't a bad guess. So there's my line. Okay. Now, I'm seeing how this is in between the lines. So even though I'm given the graph, I might have to do this algebraically. This is a scary thought to me right now. But from what we have so far, I have one solution ready to go. So this is clearly an intersection, and my other intersection is here. Now this one is the point 0, 2. So that's one solution that we have. Put that in the bank. But because this one is between the lines, I could guess at it, but that's not going to be good enough. We need to find the actual intersection. So because it's between the lines, we're going to have to do this algebraically. So here we go. Let's turn this graph of the circle into an equation. Well, the center of this circle is the point 2, 2. That means an equation for the circle is going to be x minus 2, alright, that's the first 2, squared, plus y minus 2 squared is equal to the radius squared. Now the radius is 2, so we square it, that's going to be 4. So this is an equation for this circle. Now we need to, because we need to substitute this in, we need to expand this equation into general form. So when I see that x minus 2 squared, I'm thinking x minus 2 times x minus 2. When I see that y minus 2 squared, that's the same thing. Y minus 2 times y minus 2. This is all equal to 4. So I'm going to do this double distributive property. Okay, so that's going to give me x times x is x squared, x times negative 2 is negative 2x. Double distribute again, so that'll be negative 2x plus 4. Okay, double distribute again over here, so that's going to give me y squared minus 2y, another minus 2y, plus 4. Okay, really same as last time except y's instead of x's, and this is going to be equal to 4 over here. So now I'm going to combine some like terms and stuff. So I've got my x squared, okay, and I've got my y squared. I like to put those first, and then putting these together, that's going to be negative 4x. These together is going to be negative 4y. So I've done everything except for the constants. Now eventually we're going to have to get 0 over here, so I choose to do that right now. That cancels out both of these. So that just leaves us one other 4 right here. So I'll have plus 4 is equal to 0. So this is general form. The point of putting it in this form is so I can now take my, where'd it go? My y equals 1/3 x plus 2 and plug it in for these y's. Okay, so I can bring this down. I've got my x squared, but then my y squared is where I'm going to do my substituting. Okay, so y is 1/3 x plus 2. Alright, so I've still got my minus 4x, and here comes my minus 4. Now here's another y, so I need to substitute for that too. So that's 1/3 x plus 2 again, plus 4 is equal to 0. Okay, so I've still got my x squared. Now this, I'm going to have to write it as the same thing twice. So 1/3 x plus 2 times 1/3 x plus 2. Now I've still got my minus 4x. I'm going to have to do the distributive property just once, but negative 4 times 1/3 x, that's negative 4 over 3x. Negative 4 times 2 is negative 8. And I've still got this plus 4 equals 0. If you're not sure where the 4/3 came from, alright, I'm doing 4 times 1/3. Okay, or negative 4 times 1/3. That's 4 over 1, so I just multiplied straight across. 4 times 1 is 4, 1 times 3 is 3. That's where I got 4 over 3 from. Alright, so we're going to have to do the double distributive property here with these. So I'm going to have to do 1/3 x times 1/3 x. Alright, 1/3 times 1/3 is 1/9. Alright, we're just multiplying the numerators and denominators together. So that's going to make, alright, well I'm bringing down my x squared, but now that's going to make 1/9, and then x times x is x squared. Now if I do 1/3 x times 2, that's going to make 2/3 x. Okay, so I just did that. Similarly, if I do 2 times 1/3 x, again that will make 2/3 x. And also I have to do 2 times 2, which is 4. Okay, so that brings me to the negative 4x and the rest of it. Negative 4 over 3x minus 8 plus 4 equals 0. So, time to combine like terms and such. So I've got this x squared and 1/9 x squared. Alright, you can think of the x squared as 1 x squared, or better yet, since we need common denominators, you can think of this x squared as 9/9 x squared. Do you get it? Because 1 can be anything, right? Doesn't 1 equal 9 over 9? Or anything over itself. So I had 1x squared, I could write that as 9 over 9, because that's the same as 1. But this way, 9/9 plus 1/9 is 10/9. So this makes 10/9 x squared. Alright, now 2/3 x plus 2/3 x is 4/3 x. You know what? How many of these do we have? I think I'm gonna get lazy and use my calculator. Alright, I'm gonna add this, 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 and this. So we're doing 2/3 plus 2/3 minus 4 minus 4/3. Oh, you know what? That's silly. I just said that this, okay, hold on. I feel like I should do different colors right now to make my point. Okay, negative 2/3 and 2/3 make 4/3, right? But then I have a negative 4/3 over here. See where I'm going with this? So positive 4/3 and negative 4/3, those are just going to cancel each other out. So that's my x's. So that's going to leave negative 4x. So I don't need a calculator. So that'll be negative 4x from that right there. Now that just leaves the constants. But I think it's going to happen again because I see the 4 and the 4 make 8. But then we have negative 8. So the constants all canceled out. Alright, so I have 0. So this is what I have going on right now. Okay. Now, there's a couple different things I could do, but the presence of this fraction is sort of bothering me. So I would like to get rid of the fraction. I'm going to do that by multiplying everything by 9. Okay, and multiply everything by 9. These 9s are going to cancel out. That's going to leave me with 10x squared minus 36x is equal to 0. Okay, that's fine and dandy. Now it's time to pull out the GCF. The common factor here is 2x. Don't forget they both have an x in common. So that's going to leave behind 5x minus 18. Alright, you could think of it as dividing both of these by the GCF. And 10 divided by 2 is 5, 36 divided by 2 is 18. And of course you cancel these, you get x, and these cancel, leave no x's. Alright, just however you want to think about it. Once you get these two factors, you set them each equal to 0 to get your solutions. So if I set 2x equals to 0, and if I say 5x minus 18 equals 0, then over here, I'm going to divide both sides by 2, and that's going to give me x equals 0. Uh-oh, getting a dead spot. Now, here I'm going to add 18 to both sides, so that's going to give me 5x equals 18. And dividing both sides by 5, it's going to give me x equals, well, 18 over 5. I guess I could make this into a decimal without rounding. Let's check it out. 18 divided by 5. What you got? 3.6. Alright, that's pretty clean looking. So I'll say x is equal to 3.6. So those are our two x values. Remember that, 0 and 3.6. Now we need the y values that go with them. So what I like to do is make a table of values. Alright, I don't know why I made it so big. I said what I like to do is make a table of values. Alright, x's, y's, you know the deal. Alright, it's going to be a very small table because I only have two x values. I have 0 and 3.6. To find the y values that go with them, I'm going to use this y value equation. Alright, y equals 1/3 x plus 2. Alright, let me switch colors because I'm doing something different. If x is 0, then this equation becomes 1/3 times 0 plus 2. Well, 1/3 times 0 is 0, and 0 plus 2 is 2. So that's 0, 2. But if I put in 3.6, then I've got 1/3 times 3.6 plus 2. I feel like using my calculator for that. Alright, 1/3 times 3.6 plus 2. Oh look, that's 3.2. Alright, so I get 3.6 comma 3.2. So that must be the value of this other point right here. Does that look about right? Let's step back and see, does it seem reasonable? Okay, let me make this a little bigger. So let's see. So I'm claiming that this is 3.6 comma 3.2. And yeah, see 3.6, all right, looks a little bit more than halfway. And then 3.2, just up a little bit. That looks about right, but there's no way we could have gotten those exact values just off the graph. We had to do it the long way. You can see from this distance I had to start writing small so it would fit. but I zoomed in, so it was still cool. All right. Anyway, that's your answer. Your other mystery answer is 3.6 comma 3.2. All right. I'm going to end this video here. Here endeth the lesson. We'll do more things that are similar, solving systems with a circle and a line, but we just won't be given the graph, so it'll be all algebraic in the next video. All right, I'll meet you over there. I'll meet you at number 3. Come find me. Catch me if you can.